In this video, we are going to rock one heck of a cool word problem that has to do with a walkway around a pool. A very classic kind of word problem that deals with polynomials. Let's jump right into it. The name of the game, simplicity. So if we can draw out a picture and just think of this as simply as possible, let the algebra fall where it may, we are in good shape. Let me show you what all of that means. So this says you have a square pool with a 2-foot wide walkway that surrounds it. Now before we even continue reading, that begs for us to draw a picture. So we're going to have a square, and that square is going to be our pool, right? So here's our square. Hopefully it's a decent looking square. And around that square is a 2-foot wide walkway. All right, so I'm going to do that with just kind of dotted lines just to represent it as the walkway. So it's 2 feet wide on every side. So right here is 2 feet. Right there is 2 feet. Like this distance right here is 2 feet. It's 2 feet everywhere you look, all the way around. Okay. Now, we are then told in the next sentence that the length of each side of the pool will be x feet. So let the length of each side of the pool be x feet. So here's the pool, so that's going to be x. This will be x, so this distance here is x, and that distance there is x. There we go. So now that entire, paragraph, those first 2 long sentences, have now been translated into a picture. We no longer need to read those words. What is the area of the walkway in terms of x? So we want the area of the surrounding band right here. So if you think about it, what we're really doing, keeping it simple in terms of geometry, is you're finding the area of the big square, right, the pool with the walkway, minus the area of the square on the inside, the area of the pool, which is what we don't want to find the area of. So I'm going to write that out. So that would be the area of the big square, so area of big minus area of small. And this is a lot like a previous video I did now at this point. So area of the big minus area of the small is going to get us what we need. So now what we need would be the expression for the area of everything, including the walkway, minus the expression for the area of the small. Well, the area of a square is each side length times itself. So let's take a look first at what the dimensions are here. So the dimensions of the pool with the walkway, well, this whole thing is x, but this part is 2. So you have 2 plus x plus 2. That ends up being x plus 4. And this is a point where a lot of people get confused. Over my many years of teaching, I've seen students write this as x plus 2 or 2x. Walk it out. You've walked 2 feet plus x feet plus 2 feet. So if I write that out, 2 feet plus x feet plus 2 feet, you have 2 plus 2 is 4 plus x, or x plus 4. Now this side is going to be the same length because we're going 2 plus x plus 2. And so that again, here, this distance here is also x plus 4. So now we have the dimensions of the pool with the walkway. Pretty sweet. Actually, that goes down a little bit further there. Sorry about that. So that's going to stretch all the way down to here. Okay, so now how do we find the area of the big? Well, the area of the big again is the whole square, including the walkway. That would be x plus 4 times x plus 4. Base times height, or s squared if you want to think of it as this side times that side. So the area of the big is simply x plus 4 times x plus 4. So I am following this template, this thought bubble, right? So that's the area of the big. Now the area of the small is the area of the part we don't want. It's what we're subtracting out. That would be the area of the pool in here, which is x times x, right? So that's not bad, x times x. So all that's left for us to do now is recognize that we've come up with the expression in terms of x. The instructions will likely say in simplest form, or your teacher will say all answers in simplest form. So all we have to do is now multiply and subtract, and we're good to go. So let's simplify this. Just keep in mind that if you're given multiple word problems like this, get to this point. And once you're there, you're in great shape, because the rest is algebra. Okay, we're going to FOIL. So I'll do x times x is x squared. X times 4, that's the outer term, is 4 times x, or 4x. Inner, 4 times x, 4x. Last, 4 times 4, 16. That's minus x times x, which is x squared. So now all we have to do is combine like terms. The x squared terms actually will cancel. X squared minus x squared is 0. So I'm going to check those off. 4x plus 4x is 8x. Sweet. So we get 8x plus 16. That's it. That is our area expression in terms of x. So let's say that the pool was 20 feet by 20 feet. Then I know the area of the walkway would be 20. X would be 20 times 8 is 160. Plus 16 is 176. So in general, it's about keeping things simple and ignoring the algebra. But when it gets to finding what that dimension is, walk it out and understand that you're just adding each piece together. Go rip some more problems like this.